Starting in a minute, guys. Just give me a second. Starting in a minute. Starting in a minute. Second, please. All right, let's do this. Morning, everybody. Online. Students online. Can see the screen all right?
Yes.
Yes, sir.
All right, good. So this is the paper that we did. You have to be quiet. All right, session kind of different now. All right, so and by your grading yourselves, learning from your mistakes, that's what it's all about now. All right, so I'll give you what the target markets for this week. This is very, very low as we're just starting. Right, expected to make mistakes. We have to improve on those mistakes over the time. All right, so it's going to basically run through the paper as quickly as possible. It is being recorded so that you can have it to look back at later on in case you want to see something again. Generally, we want to go through it as quickly as possible and explain the solutions as best as possible, and as efficiently as possible as well. So don't have to spend not like I'm teaching the thing over again now. I'll do all the teaching already. Right? So the important things I say, but I'm not teaching over from scratch anything now. All right. So let's go. So this was the paper. This is January 2019 paper that we did, paper 2. And I'm starting at number 1, which is our calculator question, as usual, right here. It says we have to evaluate this. We're going to use a calculator to do it. So I'm going to a calculator. All right. Right now, this calculator is in radians up there, the RAD. You always want to check that on the calculator first. I want to change it to degrees right now, just in case we do a trigonometry later. All right. So the first thing we want to calculate is this. What it is that we want to type this in the calculator exactly as it appears there, and we have to give the answer in standard form. All right. So standard form. All right, I'll show it. So give the answer in standard form. And some calculator can show you the standard form. Your calculators know that you tell it standard form or what they call scientific notation. It will do it for you and show you what it is. Well, let's put this in the calculator first. 3.8 times 10 squared. Then that's a plus in between there. And it's 1.7 times, that is 10 cubed. That's what we're doing. So we're getting initially 2080. But in standard form, you want to have one non-zero digit before your decimal point. When you have a number like this, your decimal point is automatically here at the end. You don't want the decimal point there, you want it here. That's where you want it to go. You want it to come after the 2. So standard form, you must have one non-zero digit before your decimal point, and then there's always times 10 to some power. That's how it is, and that power can be a positive or a negative. Now, generally speaking, if the number is large, then it's 10 to some positive value. If the number is very small, like 0.0028, when you put it in the standard form, it's going to be times 10 to some negative 4. That's sort of a guide like how you can know. All right? And the size of the number must not change. So let's see how we would get the decimal point here. I want this decimal point that is at the end to come 3 places back to there. To get it 3 places back, let me use the red ink and show it. To get it 3 places back, you would essentially divide by 10 cubed. So you would divide by 10 cubed to move the decimal point for you. But then you have to balance back out that division of 10 cubed. And so you also have to multiply by 10 cubed. And then this is where you do the calculation to move the decimal point. And that will give you the result. So the answer comes out to be 2.080 times 10 cubed. That is the answer. This last zero, I don't need to show it because it is immaterial and valid. But that is it in standard form. If you put it there, this one, or you leave it off, no problem. All right, that's the answer for that one. So you should all have 2 marks already. All right, let's move on. Then we want to get this one. Again, we want to put it in the calculator up there. And we are giving our answer as a fraction in lowest terms. So again, I'm just going to put it in the calculator. And it is a fraction. On the numerator of that fraction, I have another fraction, which is a half. And then I'm multiplying that with another fraction, 3/5. And then I'm dividing all of that by a mixed number, which is 3.5. And that answer comes out to decimal initially, but your calculator will show it as a fraction as well. So because I want as a fraction, I have to change my function, and this is my fraction in lowest terms, 3/25. All right, so that's what you are supposed to get for this. I'm going to say equal 3/25. Now, if you were to show some work, then what it is that you would multiply this numerator first. This time this, how you multiply, you'll be multiplying this times this first, and get 3 over the 2 times 5 is 10. And you'll be dividing by this mixed number, which is going to change into an improper fraction. I will know it's 2 times the 3 plus 1. 2, 3, 6 plus 1 is 7/2. And then when you divide by a fraction, you invert and multiply. So I'll move this answer down here. We know what the final answer is. We just want to show some work this time because why am I showing some work? Because the question did not say using a calculator. That's why I'm just saying, let me show some work. But then if you're working this out now, it will be equal to 3/10, that's the numerator, divided by that fraction. So you invert and multiply by 2/3. And then you simplify this now. 2 into this goes 1 time, 2 into that 10 goes 5 times. All right, and I'm not having this. Oh, this is 7. Oh, this is 2/7. My mistake. 2/7. This is 2/7. All right, that's it, 2/7. So the 2 goes into this, as I said, and 2 into that goes 5 times, 2 into this goes 1, and then it will be 3 times 1 is this 3, and this is supposed to be 35, not 25, another mistake. All right, not starting out so well. Right, the 3 times 5 is that 35 there, so that's the answer. So I had the correct thing here, but I wrote the wrong thing. But that's all right, this is the correct answer. 3/35. All right, so that's the answer right there. So that's another 2 marks. Let's continue. Here we have to express this in binary numbers. Binary numbers is base 2. So to do this, what I'm going to do is show you the place values for binary numbers in the binary system. So first place value is 2 to the 0. Then you would have 2 to the 1. Then you'd have 2 squared. Then you'd have 2 cubed. And you'd have 2 to the 4th power and so on. Those are your place values. This 2 to the 0 is 1. This 2 to the 1 is 2. This 2 squared is 4. This 2 squared is 8. and this 2 to the 4th power is 16. Those are just your place values in the binary system. Those are your place values. And how the binary system works is that this number 6, you want to use a combination of these, one time or no time to get it, because the binary system only accepts values 1 and 0. So the 1 is when you're using a place value, the 0 is when you're not. All right? So in this case, because I'm doing the number 6, I look for the first number this way. The first number here that 6 can go into, going from left to right. The first number that 6 can go into 6, I should say, is this 4. So it means that I can use the 4 out of the 6. So I'm putting 1 to say that I'm using the 4. After I use the 4, I'm going to have 2 left to make up the 6. 2 left to make up the 6. So it means that I'm also going to be using this 2. So I'm putting 1, so yes, I'm using the 2. But then you also have to complete all the places. So I'm not going to be using this 1. So I'm putting 0. So that is the number 6. This is number 6 to base 2. So if you want to write the answer here, you're going to say 6 to base 10 is equal to 110 to base 2. That is the answer. All right? Want to go to that? All right, good. So that is how it works. I don't want to spend a lot of time on anything today, because I say I'm not really teaching from scratch. All right, so that is it. This one now. This one says, John bought a car for $65,000, and it says, if the value is depreciated, or if the value depreciates by 8% per year, each year, how much will the car be worth after 2 years? If you are depreciating by 8%, it means that the value of the car after the depreciation is 92%. I'm doing the mathematics the easy way. The value after the car after the depreciation is 92%. You subtract 8% from 100. That's going to be the value of the car after you depreciate it. I want to know what the value of the car is. The value of the car after the depreciation is 92%. They did not ask me for the depreciation value. I don't need to calculate the depreciation value. So if you take off 8%, you're going to have 92% left. If you took off 10%, it will be 90% left, and so on. So I want to know what the value of 92% is, and I'm doing it 2 years. So we can do it step by step. And we can do one calculation. So year 1, after year 1, or year 1 end, the value is going to be 92% times the original value of 65,000. I do have to work this out yet, you know. I don't have to work it out. 92% is 0.92 or 92 over 100. So I can write this as 0.92 times the 65,000. But remember, guys, I said to you, you want to use the calculator one time in the questions. So I don't need to work this value out. I don't need to work it out, because I can carry this as the value that it is to the next year. So I'm going to depreciate this value now again by 8%. So I'm going to apply another 92% now to this value without working it out. I don't need to work it out. You have to practice to save time in the exam room. So therefore, what happens? If you want to work it out, no problem, but you don't need to. So I'm going to say the year 2 value then, the year 2 end value will be equal to now 92% of this. So it's going to be 92% times all of this. 0.92 times 65,000. So you're really doing a 92% squared. That's what it works out to. 92% squared of the value. So you apply 92% and you apply 92% of that result. So it really becomes 0.9. Yes?
How do you get the 0.92?
Or get the 92%?
No, the 0.92. Yeah,
Because
that.
92 over 100 is the same as 0.92.
So why do you have to why can't you just use the 92%? Why do you have
If
to?
you use the 92%, no problem, the same difference. If you put 92% in the calculator to work it out, that's the same. But the actual value of 92% is 0.92 because it's 92 divided by 100 in value. All right. So if you want to work with the 92% and say percent and put percent in the calculator, that's fine as well. Okay. But I'm going to do I'm going to do 0.92 squared. 0.92 squared now. Because this is 0.92 and this is 0.92. 0.92 squared times 65,000. That's going to give me my final answer. Now, if you work it out step by step and calculate each part and so on, no problem. But I'm going to work this out now. And I'm going to put it in like that. So I'm going to put 0.92 squared times 65,000. And the final answer here is 55,016. That's the final answer. So if you did it step by step and you get this answer, no problem. That is still the correct answer. Now let's see if I put 92% in the calculator, if it would work. Let's see. This calculator will do it that way. Let's see. 92%. If I put 92, where's my percentage? I don't even see the percentage on this calculator. I don't see percent. So since I don't see the percent, I would have to put it as 92 over 100. Answer is going to be the same. Right? But some calculator, you can put the 92 and the percentage symbol and to read it as 92. Oh, so the percentage symbol here, I find it. I just found it. Let's see if I put it that way, what I would get. Let's see. Let's see. Let's see. All right, so I'm going to put 92 and put the percentage. See, it works out just the same. So if you have placed a 92% there and then square it, you get the same answer in the calculator. All right, see that, Alexia?
Yes, sir, I saw it.
All right, good. So you could have worked with the 92%, just the same. All right. Okay, but there are 2 more marks. Remember, I know, target mark is 25 or more. 25 or more, because this is the first one, progress before perfection. So once you get 25 or more, I'm good. All right, so everybody should be able to get 25 on this paper. But let's continue. All right, more you get, the better. This question now says, the table below shows the results obtained by a student in her CSEC math exam. It says the maximum mark for each paper is given in the 3rd column. So this is the maximum mark that you could possibly get. And see, it already add up to 100. And these are the marks that you actually know. These are the percentages that she got. So basically then she got, for example, 55% of that 30. She got 60% of that 50. And she got 80% of that 20. To know what the total mark is. And let's calculate the total percentage. And since the total is already out of 100, whatever you get as a total marks here is also going to be a percent. Right? Because it's already out of 100. So our mark is going to be 55. Okay, now we can't talk here. Hello. We're online. And we can't have that noise. Get me? Just make sure just hear one voice alone going through the speaker, please. So the unnecessary chatter, please. All right. 55% times 30 plus 60% of 50 plus 80% of 20. I add up all of those and I can just put one figure, one answer. I don't have to show each figure. Because I'm not asking for each figure. I'm just going to put everything one time. So it's 55% of 30. And since I know the calculator can do the percent now, I'm going to do it that way. 55% of 30 plus I want 60% of 50 plus I want 80% of 20. And that's 62.5 out of 100. Total was 100. So got 62.5 out of 100. And we can say that is still 62.5%. That is the answer right here, 62.5%. So let me bracket this up and shift this up here. All right, she got 66, she got a total of 62.5 marks, and it's all out of 100, and so it becomes 62.5% anyway. And that is the answer. This right here is the answer. And everybody should have gotten that full 9 marks on this question. All right, question 1 done. Everybody good? All right, beautiful. Let's go. Next question. Should need a calculator right now. All right. This next question wants us to make x the subject, quick and fast. So we are transposing away everything from the x. We are transposing away everything from the x. So I'm deciding I'm going to move this 3p first and bring it over here and subtract it. So my first line is going to be y minus 3p equals x over 5. Then I want to move this 5, but it is dividing. So I have to multiply it across the entire side. So I multiply it across. I'm going to get 5 into y minus 3p equals x. You can leave that as a subject, i.e. x equals 5 into y minus 3p. That is it. If you left it in an expanded form, it will be 5y minus 15p. Either this or this, good to go. So I can say that or that. That is it. And one of those you wrote, that is the answer. 2 marks for that. Easy. This one wants us to solve this equation. It is sort of quadratic, but it's only 2 terms. So don't need the long process factorization. It's only 2 terms. All right? I'm going to factorize it still. Common factor in these 2 terms right now is x. I'm going to factorize the x. Don't divide it out. I must never ever, and it says by factorizing. So it's actually helping you. So you factorize the x, which is a common factor. You have to 2x minus 9 equals 0. So then it is either the x equal to 0 or this thing in the bracket equal to 0. When you multiply 2 numbers, because this is this times this, and the result is 0, then one or the other is 0. So either the x is equal to the 0, that is this x, or this is equal to the 0. And we can just write the answer. Because if this is equal to the 0, you would carry over the 9 first and get a positive 9 and then divide under the 2. So you would get x equals a positive 9 over 2. Everybody can say that? Those are the 2 answers. Beautiful. Let's go. Next question. 2 marks again. This one now. It says a farmer wishes to enclose a rectangular plot with a wire fence. The width of the plot is 3 meters less than the length L. The length is L and the width is 3 meters less. I'm going to sketch it so I can see exactly what he's saying. So the length is L, but the width is 3 meters less. So the width is L minus 3. And they're telling us that that area is 378 meters squared. 378 meters squared. So it means that the length times the width is equal to this. That's what I'm going to say. Right? Because they're telling us that the area is that. So the length times the width. So this, based on this sketch, I can say the length times the width is equal to the 378. I don't need to put in the meters. All right? And then if I expand this side, I'm going to get L squared minus 3L equals 378. We are working towards this, so we see that we only need to transpose this 378 on this side. Mute the mic, please. Somebody's mic is open. And so L squared minus 3L minus 378 is now equal to 0. And that is shown. That was shown. What go to that? Nice and easy. Another 2 marks. Like everything is 2 marks. All right, beautiful. Next one. Let me get back the blue ink. Next one. We're going to do the mathematics the easy way, guys. All right? So this one says the force F applied to an object is directly. Remember, once it is directly, it is K times. So the first thing is directly proportional to the second thing, which is extension. So that means that the force is equal to the constant of proportionality times the extension. Simple as that. So we have to write a formula or an equation representing the relationship where K is a constant. That is it. If it was inversely, then it would be F equals K over E. If it was inversely. If they had said inversely instead. Inversely, but they said directly, so it's K times. Now, this is an example where they don't ask us for the K value. Look, they want us now to complete this table. It says the incomplete table below shows corresponding values of F and E. We have to use the equation to determine the value of X and Y. They don't need the K. So I'm going to do it away where we don't calculate the K. So when you're not going to calculate the K, what you can see what the K will always be equal to because the K is a constant. So based on this relationship, if I divide by the E, I'm going to see, let me just write it down here, that if I divide by the E, I make K the subject, then F over E is equal to the constant. It means that the F over E is always constant. The F over E is a constant all the time. So we can start that way. Watch this now. The constant is always equal to the force over the extension. So therefore, for example, this force over this extension is equal to this force over this extension. And that's how we can calculate the X. You get me? So we can set it up like that. So we can say 25 over X will be equal to 60 over 1.5. We can cross multiply. But watch this now as well, to make it mathematics even easier. If, because the K is a constant, if the F over E is always equal to a constant, then it means that E, another constant, let's call it K1, is also equal to E over F. E over F is also equal to a constant. Because the reciprocal of a constant is constant still. So the E over F for one pair will always equal to E over F for another pair. I want to do the mathematics the easy way. So for this pair, I'm going to use this relationship, that the E over F is always constant. So look, I'm going to set it up now. So this E value over this F value equals this E value over this F value. So I'm going to say X over 25, that is E over F, is equal to 1.5 over 60. Or if you want, you could use a 0.2 over 8. Doesn't matter, either one. So using a known pair. And then to find the X, I just need to multiply the 25 up here. So the X is going to be equal to 1.5 times 25 over 60. Write that better. The pen giving me hell. 25. That's first value. I'm going to get a first value by doing that. And then for the second one, I'm going to put now this Y over this 3.5 will be equal to 60 over 1.5. Because that's a constant, right? So I'm going to say Y over, not 3.5, 3.2 will be equal to 60 over 1.5. The force over the E will equal to the force over the E, constant at all times. That's the easy way to do the mathematics, because this question is not asking us for the value of the K. So in this case, the Y, just multiply the 3.2 up here, will be equal to 60 times 3.2 divided by 1.5. And I get my Y value that way. All right, let's do the calculations now. Quick and fast. All right, if you do it another way and get the same answer, no problem. So I'm going to do 1.5 times 25 divided by 60. I'm going to get 0.625. Anybody got that when they did it? All right. And the y value is good. Let's do the y value now. I'm going to get 60 times 3.2 over 1.5. And it's supposed to be 128. Anybody got the 128? So if we did it another way and got that same answer, you're good to go. All right, no problem. So some persons maybe did it by finding the k, because we practice that way. So the reason why we practice finding the k when we did, because a lot of the questions will also ask you for k. But I'm showing you now how you can do it when they don't ask you for the k. Just look what the k equal to in terms of the formula. And that combination will remain constant for all the pairs of values. I don't have to actually find the k. Have you noticed they don't give a lot of space to work to calculate two values? You get me? All right. More maths equals better maths. Let's go. Next question. All right. So this now, I know we didn't do this topic as yet, but I'm still going to do it. So that after we do it, we can still look back at the solution. And some persons would have learned this topic already. So, all right. So when doing these questions, right, I always say sketch it before you construct it. All right. I always say sketch it. Make sure you get the right, based on the information, based on the instructions, sketch it, then you construct it. So they're saying using a ruler and a pair of compass only. All right. You say, can't use a protractor, you know. You can't use a protractor for your construction. Ruler and a pair of compasses only. You want us to construct a right angle triangle ABC such that AB is 5 centimeters. Let's put that here. Let's do a little sketch of it. What we're going to construct. So we're going to draw a line AB 5 centimeters. AB is going to be 5 centimeters. Then we're going to construct the 90 degrees at the B. Because the B is in the middle right here of this angle ABC. So the 90 degrees is going to be at the B right here. And then the angle at C is have to be 60 degrees right here. So we're going to construct a 60-degree angle down here. And when it's joined, it's up here, it's going to be C. So we need a 60-degree angle down here. Let's do the construction now. All right? I'm going to do the construction for you. Let's go. All right. So I'm going to do the construction on this. I'm constructing that triangle over here. All right. So this is it. Now I'm constructing this triangle. All right. So first thing I need, all right, I've not used this in a while, right? So if you see me going back and forth a bit, then you understand. But first thing I need is my 6 centimeters. Now you can use your compass to get the 6 centimeters by bringing in your ruler. Right? As sometimes you can just use ruler. Question did say use a ruler and a compass. I can use a ruler and draw the 6 centimeter line. So measure from 0 to 6 on the ruler. All right. So measure from 0 to 6. And you stop at 6. But what some persons do, they draw a line longer than 6. Let me show you. To show that they use the compass. They draw a line longer than 6. All right. Position the ruler up here, for example. They bring in the compass and they position the compass on the 0 there. Go on the 6. All right, that's it. And then they open it up to 6. Like that. And then you lock it. I'm going to change the color to the construction lines. All right. Remove the ruler. Then you come here to the end of the line and you mark your 6. You mark your 6. Mark where the 6 is by doing that. Right? So that's where the 6 would be. And then you can basically sort of label it. Well, let's not label it. So that is the AB. Then I'm going to do a construct the 6 centimeters now. Let's change the color for the construction. So let's change the color to blue for the construction lines. So to do the construction for 60 degrees, it is the easiest angle to construct. So you hold your compass a reasonable distance, you lock it, and not go and change that lock again. You lock it. To do a 60-degree angle, you only need two arcs that intersect each other. Right? So you make an arc first. You can make it kind of longish to about where 6 centimeters, 60 degrees would be. Then when you move the point to this intersection of the line and the arc, and then you rotate up the compass and you cross that arc, then the straight line through the intersection and the starting point will be 60 degrees. Not going to draw it yet. I'm going to construct the 90 degrees now over at B, where the red arc is over here. I'm going to construct the 90 degrees here. Construct 90 degrees, there are multiple ways to do it. All right? Some persons, they construct a 180 and then bisect it. But I construct a 120 and bisect the second 60. That's the method I use. I construct a 60 and a 60 and then bisect the second 60. When you bisect the second 60, it becomes 30. So 60 and 30 makes it 90. If you have another way to do it and you're comfortable doing it the way you do it, no problem. But look at my method. So my method, let me close up the compass a little bit. I don't want this in the way. Let me close it up a little bit. All right. I'm going to construct the 260-degree arc. So because I want a 120-degree arc, I come all the way around here. A long arc all the way around there. A long arc. Then I move the point to the first intersection here with the line, and I cross the first arc. Cross the arc one time first, right here. That's 60 degrees. So I have a 60-degree arc there. And I move the point of the compass here to this intersection. Not there, on the intersection. See that? And when I make another arc, that's a second 60-degree arc. So right up here is a 60-degree arc. I'm going to bisect it. So to bisect that now, and put the point here again. And I'm going to bisect it by putting an arc above it. Put the point over to the other arc down here. And I want to cross this one. So that is me bisecting the second 60. You would use your ruler. I'm not going to use the ruler, but you would use your ruler and draw a straight line through this intersection. See, through the intersection of the first side, that's the 60. Use your ruler and line it up and draw it. Then I'm going to draw my 90 like this through this point on the red where the B is. That's not the right place. So let's move that out the way. I don't want to delete, because if I delete, I might delete everything. Right, I'm going through this intersection. That's a 90 intersection. Through the 90 up to here. Where those lines meet, that would be my 90. Through the intersection. Not so accurate because it's automatically making connection at the top. We want to go through that arc there. That would be 90. So basically, right here will be 60 degrees. And right here would be 90 degrees. This point will be A. This point will be B right here. And up here will be C. Very good? All right, leave it for that for now. We're going to do this topic formally. All right? But that's how that to be done. Was there anything else we required to do on this question? No, that was it. Sometimes they ask to do some other stuff on it, but that was it for this question. All right, anybody got it right? All right, so those of you who learned this topic already should be okay. And that's why I teach these things I teach these things last, because I know most people already know how to do them. You get me? But that finishes that question. Next question, part B. So let me take this off now. It gives us this right angle triangle. Remember, once it's a right angle triangle, you're good. Pythagoras' theorem, so-called tower. All right? Everything about right angle triangle, Pythagoras' theorem, so-called tower. It says, the diagram below shows a right angle triangle with sides A, B, C, A, B, and C. A units, B units, C units. It says, use the diagram to express C in terms of A and B. Has to be Pythagoras' theorem. Has to be Pythagoras' theorem. C is the hypotenuse. So I'm going to write that C squared is equal to A squared plus B squared. But simply because they said C alone in terms of the A and B, I'm also going to write that C becomes the square root of A squared plus B squared. I'm going to give them this as well. I think this is what they're really looking for. But if you wrote this alone, I think they'll give it a mark still. That is still true. All right? So if you wrote this or you wrote that, I'll say take the 1 mark. Right? Both of them correct. But because they said C in terms of A and B, I would prefer to have C, not C squared, as a subject. You get me? But let's continue. Then it says now, write in terms of the A and the B an expression for sine theta plus cos theta. So let's write it out. Sine theta plus cos theta. Let me write it like this. Would be equal to, what would be the sine theta? Sine is opposite over hypotenuse. The opposite is the A, don't it? This is the opposite to the theta. This is the adjacent to the theta. Adjacent. And right here is the hypotenuse. So if you want the sine, it becomes the A over the B, don't it? No, the A over the C. My mistake. Opposite over hypotenuse. A over C. And the cos theta is B over C. What say that? So it becomes A over C plus B over C. That's it. A over C plus B over C. Now, because they have the same denominator, we can consolidate and write it as A plus B all over C. All right? That's good. If you leave this or you leave that, they'll give you the marks. All right? Let's continue. Next part now says, using the results from A1 and B on page 2, show that this. Now, this is like an identity that trig students must know, especially in AdMaths. Back in the day when I did CSEC, I had to know this. That sine squared plus cos squared is 1. It works out. So it's like you're combining the trig ratios and combining the trig ratios with Pythagoras' theorem. So let's set it up. We're going to work out this side first. The sine squared plus cos squared. So the sine theta squared plus the cos theta squared. This one was A over C, don't it? So this is A over C squared plus, this is B over C. B over C squared, which then becomes A squared plus B squared over C squared. But I say that? But remember that in part 1, this thing up here was equal to C squared, remember? In part 1, the C squared, remember, was equal to A squared plus B squared. In part 1, right here. So we have 2 options. We can substitute this under here for the C squared, or we can substitute this up here for the A squared plus B squared. Either way. So let's do it that way. Let's start replacing this with C squared. So then we're going to therefore write this as C squared over C squared, which then works out to be 1. And that is it shown. But I go to that? But okay? So to prove this is a combination of the trig ratios and Pythagoras' theorem. That's not the only way to do it, but this way good enough for now. That's another 9 marks. Hope everybody reached 18 marks already. out of the 25. All right, let's go. Next question. Number 3, functions. So it gives us this function, and it says we have to determine the value for which the function is undefined or not defined. Remember, a fraction becomes undefined when the denominator equals 0. So any value of x that would make the denominator 0, fraction can't work. And when the fraction can't work, the function can't work. So it is undefined when the 5 minus x is equal to 0, which is when, that is when the x is equal to 5. So that's the answer. X equals 5 will make the function can't work because it makes the denominator 0. It cannot divide by 0. So the function cannot work when x is equal to 5. It means that 5 cannot be in the domain of the function. 5 cannot be a value in the domain. Function can't take a value of 5 because it becomes undefined when x equals 5. So that is the answer. 5 is a value that will make the function undefined. Another way they phrase this question is, what value of x cannot be in the domain of h of x? Still be 5, the value that will make it undefined. So the answer will still be 5. So that's another way they might phrase the question. What value of x cannot be in the domain? That value cannot be, that value is 5. Cannot be in the domain, but it will cause a function to be undefined. Okay, you can't divide. And if you want to actually see it, if you put 5 in there, just to show it, 2, 5 is 10, and 3 make 13 over 5 minus 5 is 0. If you divide 13 by 0, the calculator can't work. It will be a math error, syntax error, some kind of error. Let's just show it. Let's just show it for the purpose of maybe those who are not so clear on what we're saying. You cannot divide by 0. Any value that will make the denominator 0 in a fraction is causing the fraction to be undefined. So see here, fraction 13 over 0. The character give you a division by 0 error. That's an error message right here. You cannot work it out. Cannot work it out. If you do it on your calculator, it will give you an answer like syntax error or something. Different calculators will state it differently. All right? Function is undefined and the denominator is 0. All right, let's continue. Don't need this up here. All right, next part. The next part wants us to find h to the minus 1. So they give all 3 marks for that. Because I know that is a number of steps to do it, right? So let's do it. All right. What is the function again? It is 2x plus 3 over 5 minus x. I'm going to start by saying h equals 2x plus 3 over 5 minus x. That's a function. I'll just leave off the of x of that for the time being. Some teachers call it y. Same difference. I give by the same letter as a function. All right? So now I'm going to take the inverse. When I take the inverse, this h, which represents range, becomes domain, which is x, equals this x and this x. Each of them represent domain. They're going to become range in the inverse function. Range in the inverse function, I write it as h to the minus 1. Some teachers just write it back as a y over there. No problem. So I would write 2h to the minus 1 plus 3 over 5 minus h to the minus 1. So this is like your original function. This is the inverse function, just that we don't yet have h to the minus 1 of the subject. So we now need to make h to the minus 1 a subject. So it's a transpose thing we have to do now. As always, it's the same process. You want to spread out it and separate out the terms. You don't want them dividing each other. You want to separate them out into separate terms, so you can group the terms in h to the minus 1 on one side. So the first thing is to expand it out into separate terms, and we do that by taking this denominator and multiply it across here by the x. All right? So to multiply the denominator across here by the x is going to be the x times the 5 first, gives me 5x, and then x times the minus h to the minus 1, I'm going to get minus x 2h to the minus 1, and this remains on the right side. 2h to the minus 1 plus 3. Let me shift this over because I think I'm going to have to divide the space to do it. So I keep telling the guys I don't give a lot of space to do this work. Then now I'm going to take this h, let's group them on this side. Let's group the h's on this side. Why am I doing that? Because this is negative. So I don't want to bring this over here and have a lot of negatives working with. So I'm going to bring this over onto this side and make it positive and take this over here. So I'm going to bring this over onto this side and take the 3 over here. So when I bring over the 3 first, I'm going to have 5x minus 3 equals 2h to the minus 1. And then this goes over this side, comes up positive. So I get plus x h to the minus 1. I'm going to continue on this side of the page now. And that's what you have to do in the exam room as well. If you don't have enough space, divide the space. All right. So I'm going to factorize the h to the minus 1. So I'm going to have the 5x minus 3 equals h to the minus 1 into, out of this is a 2, out of this is a plus x. Then I need to just take this 2 minus 2 plus x and divide it under here now. Or it's like we're dividing both sides by 2 plus x. Same thing. Same thing. Whichever way you want to look at it, all we know is that this thing coming under here. So we're going to get 5x minus 3 over the 2 plus x. That equals the h to the minus 1. And we're done. So we can write the answer. Let's just use a different color for the answer. It's that h to the minus 1. We're putting in back the of x now. It's also a function of x. It's equal to 5x minus 3 over 2 plus x. If you got that, good to go. All right? If you got that, good to go. Some persons might have gotten this. Some persons might have gotten this. If the group's on the left side, they might have gotten this. They might have gotten 3 minus 5x over minus 2 minus x. It's the same thing. All right? It's the same thing. All right. But that is the answer right here. Nice and clean. 3 marks for that. I want it. We want those 3 marks. So if you never get this right, you need to go and do it over by yourself. Again, practice it. More math equals better math. Do it 5 times if you have to. All right, let's go. Next question. All right, I like these questions. Why? Because a lot of the times you don't have to calculate nothing. Everything is right there on the graph. They give you a line on a graph and it's called a geometry. You can see the gradient. You can count out the gradient. You can see the y-axis intercept. All these things. This line has a negative gradient. I want to have a negative gradient because going from left to right, it is sloping downwards. So it has a negative gradient. So if you calculate the gradient, it has to be negative. Don't give it away. All right, let's see what it says. Question says, the graph below shows a straight line intersecting the x and the y-axis. So this is the x-axis intercept. This is the y-axis intercept. Let's put in the values. Right here is a 5. Right here is a 5. It intersects at 5. Here is this is 1, 2, this is 3, this is 4. So sometimes they leave off these things to throw you off. You have to make sure you count. So right here is 4, it intersects the y-axis. First part is for us to determine the gradient. It said determine. So they're not telling you how to do it. Gradient is rise over run between any 2 points. So I can look at these 2 points, here and here, and see what the rise is and what the run is to go from this point to this point, from left to right. I have to come down first. That will be my rise. That will be a negative 4 rise. Why is it negative? Because I came down. I came down. Then I go to the right, 5 units. 5 units to the right. That is my run. So the gradient is negative 4 over 5. I don't need no calculation for this. All right? So I'm going to tell the examiner that my gradient is rise over run. It is negative 4 over 5. Get the mathematics the easy way. Get it the easy way. Any 2 points, count the rise. Rise, number of units you rise over the number of units you run. But okay with that? But good? All right, good. Next part says we are to get the equation. No problem. The equation is y equals mx plus c when you know the m and you know the c. We know both of them. The m is the minus 4 over 5 and the c is the y-axis intercept right here is the c. Right there is your c value. C equals 4. So the c is equal to 4 down here. So the equation then is y equals minus 4 over 5x plus 4. Done. Quick and fast, nice and easy. Good? Another one mark. Next one says we have to determine again the equation of the perpendicular line which passes through P. A perpendicular line has a negative reciprocal gradient. So if this is the gradient of the original line, I want a perpendicular line, it has a negative reciprocal gradient. Let's call this other line, line 2. Let's call it, so the gradient of line 2 equal minus 1 over the gradient that we have. This calculation is done quickly by flipping this one and changing the sign. All right? Negative reciprocal. Perpendicular lines have negative reciprocal gradient. So if you have one gradient already and you want to get the next one, you flip the one that you have and change the sign. And so it becomes 5 over 4. When I flip this and change the sign, it becomes 5 over 4. Then it passes through the point P. The point P is right here. That point is 5, 0. Not 0, 5, no, 5, 0. So that point is 5, 0. So P is a point 5, 0. So you want to line now with this gradient passing through this point. We can use the BFF formula. Let's do it in purple now. So the BFF formula is y minus yp equals the gradient of that line into x minus xp. So the gradient is coming here, and the coordinates, the 0, which is the y value, is coming here, and the 5, which is the x value, is going there to get the equation. Remember these things. So it's y minus 0, the y value at the point is 0. The gradient of the line we're using is 5 over 4 into x minus the x value at the point is 5. This is immaterial, so we can just expand this out and write y equals 5 over 4x minus, they multiply this 5 by this 5, get 25, you get 25 over 4. That's the answer. All right, 2 marks for that. Okay, I don't want you all just focus on writing. Remember, the thing is being recorded. You have time to go back and watch it. Focus on understanding what we're doing rather than just writing off the board. All right? Try to understand what we're doing. Listen to what I'm saying. Focus on listening to my explanation. You can go back and watch the video and write what you want to write. And we do the questions. All right? You hear me, Miss Kelsey? Come here, talk, and you still have bright and right and right. Get it in your head before you put it in the book. Get it in your head before you put it in the book. Understand it before you write it. It don't make sense you write down something you don't understand and go and toil over it. It's being recorded, and you're going to get the recording. You have the whole day. It's supposed to give you a whole time to this thing going forward now, you know. So now watch YouTube or kind of something all the while. Using YouTube time now and watch them something. And stop play TikTok and watch TikTok and play games. Time to watch maths and practice. All right, but that foolishness no more. Come on. We can do this thing. All right, next one. Talking to the people online as well. By the way, them still there. But good?
Yes,
I know you know.
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. All right, good. If you drop off, you know, send more message, you know. You know, so drop off, you know. All right, don't bother drop off. All right. See, we can keep this one. All right, let's go. Next question, number 5. Hope everybody reached 25 marks already. I'm going for extra now. Yeah. Yeah. So we can see how much more than 25 we can get. All right. Progress before perfection. Start low and build up on it. All right. Let's go. We're just starting now. So let's go. This one says, a survey was conducted among 48 persons. So everything important. So I know that the total number of persons must be 48. I'm going to write it out here from now. Total number of persons is 48. I don't want to lose sight of anything. To find out what mobile phone or what mobile network they use. The table below shows the results. So you have WireTech, 20 persons use WireTech. That's only like cable and wireless. Digilec, 12 persons, that's only like Digicel. O-Phone, that's all like Flow, 10, and then other. All right, so you see they're trying to use up some of the existing thing and just be creative. You get me? It says, if this information is to be represented on a pie chart, what is the angle for the sector for the O-Phone? That's this one. So remember, the sector angle is a fraction of the 360 degrees, matching the fraction of the number of persons out of the total. Get me? Good. So that fraction of the 360 degrees that the O-Phone will occupy. So see here now, O-Phone. O-Phone. The O-Phone angle is going to be 10 over 48. That's a fraction times the total angle in the pie chart is 360 degrees. What I work out to? 75. 75 degrees? Yes, all right, 75 degrees. That's it. We are going to need the others. So even though this question don't ask for the others, we're going to need them because the question asking us to draw the pie chart. So we're going to need the others. We don't have to work out everything because watch this now. If the 10 persons is 75, then 20 persons must be twice as much, don't it? You have to work out everything, you know. 150, so we can make a known. So let's put them under here. So this one is 75 degrees. This one has to be twice as much, which is 150 degrees. All right, and then when we get this one, this is also going to be twice. So let's make it easy for you. So we need to work out this one now. This one going to be what? 6 over 48, don't it? Which is what? 1/8. So let's work it out up here. Let's work it out up here. Let's put a little note here. So this is our answer for the question. We're going to say and. Let's do it here. So I'm going to say and. Let's make a note. The others, or the other, is going to be 6 over 48 times 360 degrees. What I work out to? 45 degrees. And so if this is 45 degrees, let's put it now, then this has to be 90. Twice as much. Because the number of students is, number of persons is twice as much, so the angle must be twice as much, right? So these are the angles that we put in the pie chart. And they gave us one, and they put that line to start for us. So starting from there. So let me do it on a construction now and show you how we do it. Everything important, right? Let me show you how we do it over here. Let me show you how we do this again. Clear. All right. So I'm going to draw a circle, and sometimes the question will tell you to make a pie chart of radius 5 centimeters or 4 centimeters or something like that. Right? Sometimes they actually do that. But let me draw one and let's basically try and start with something like that and then proceed and show you. All right, so I'm going to do that. And I'm going to put a line in here, similar to what they gave us. And I'm going to bring in that thing as protractor. I'm going to measure the angles and show you, right? Everything important. So the first angle we want, Let's put them in the same order that they are. I want 150 first from this line. So I'm going to put the eye on the point right here. I'm going to rotate to the line that I'm measuring from. And I'm reading the 0 scale. Look at it. It has 2 scales. See it? It has a 0 scale and a 180 scale. So I put the baseline on the line that I'm measuring from. But I say that. And I'm measuring the 0 scale, the one that starts from 0. But I can say that over here, that way. The 0, I have the 180. So the 180 counts down, the 0 counts up. I want 150 degrees. I'm measuring the 0 scale all the way around to 150. I'm going to put a dot at the 150 mark over here. See it here, 150 is over here. You see that? Where I put the dot? Right here, put in a dot right there. But you can see that? That's the 150 mark on the 0 scale, correspond to the 30 mark on the other scale. So if I move this a little bit, and I draw my line out to that dot, as if I'm drawing a line out to that dot, but I'm stopping it right there. You see that? That's my line. That's my first quadrant. That would be my 150. I'm going to write wire tech in there. Let me just put WT for now. Or wire tech, and the angle is 150 degrees, right? But I go to that. Then from that second line that I just drew, I want now 90 degrees. So I draw for that again. I rotate it around to the baseline. Put the line that I'm measuring from on the baseline. And I want 90 degrees. All right. So with the 90 degrees, it doesn't matter which scale. 90 degrees is 90 degrees from either end. But still practice to read from your 0 scale. I'm going to put a mark at the 90 down here. See it there, so? This mark. What is it? Put an arrow to the mark that I just made. Let's move this out the way again. And I'm going to draw that line. Out to this mark would be 90. See that? I'm going to stop it there. That's 90 degrees. That one is for Digilec. So I'm going to write my Digilec, DL, Digilec, and that is 90 degrees. But I go to that. Then I want 75 degrees from that line for O phone. 75 degrees from that line. So I'm going to bring back this thing. Rotate it again to the baseline. Oh, don't move, don't move, don't move. Right? I'm going to rotate it. Why is it moving? I want it to rotate. It's not, okay. All right. All right, put the baseline through 0 again. The line that I'm measuring from must pass through 0. And they're measuring 75 degrees on the 0 scale. The 0 scale is the inner scale. Can you see it? So 75 degrees is right here between the 70 and the 80. You see this mark, this line? No, not there. Right here. Right, that one. So I'm talking about that mark right there. Let's move it out the way and then draw a line out to there. Out to this mark would be 75 degrees. Good. I'm going to put, that is what now? O phone. Let's put OF for O phone. OF. And that angle is what? 75 degrees. And what remains is other. Let's put O for other. And that is 45 degrees. And that should be your pie chart. But look at that. That's what you are supposed to get. But all right, beautiful, beautiful. You never get it, no problem. Go and do it again. More maths equals better maths. All right, so would have drawn that part. I'm just kind of draw it on the diagram. So that at least it's on the diagram. Let me just join some of these lines. So based on this, the 150 was all the way out here, almost horizontal. Then the 90 was straight down here. And then the about here we got to the 45. And that line look like that. Can't draw straight. Anyway, so this was Digilec. This was Wiretech. This one is O for O phone, 45 degrees, 150 degrees, 90 degrees, 75 degrees, and down here is O phone. So that's what it's supposed to look on the paper. But these are straight lines, right? So even though I can't get it straight, you have to draw it. Let me draw it straight again. One more time. Good enough. That's it. All right, that is it, guys. Let's move on to the next question. All right, this one now. It says the incomplete table below shows the results obtained by 200 boys and 250 girls on a Spanish exam. So it says, so they look at it. So they give the grades for the girls, 1, 2, and 3. Those are passing grades. They did not show the failing grades. And they don't add up to, this don't add up to 250. So it means that we have some people in here that we don't know. Then they give the 38 persons who failed, and they did not show the persons who passed up here. So the person who passed up here must be 200 minus 38, don't it? That's all? Good? We can fill that out from now, you know, because they must have somewhere where we need that information. So all of this is 200 minus 38, don't it? So 200 minus 30 is 170, minus 8 more is 162. So this is 162. So everything here is to add up to 162, right? Agreed? And then this add up to what now? Somebody work out this one for me. Let me get a calculator and do it. For the persons who failed. Over here, that is 62 plus 75 plus 90, 227 that, and subtract that from 250. That's 23 persons. So here, we had 23 persons. 23 persons who failed on the girl side, right? All right. Question says, a girl is chosen at random. Determine the probability that she achieves a grade A. We're talking about out of the girls. It's only 250 girls you have. So your probability is out of the 250 girls. How many got grade 1? 62. That's 62 out of 250. That is it. You can maybe put it as a lowest fraction. 62 out of 250. Bring it down to the lowest fraction. That is 31 out of 125. That's the answer. 31 out of 125. Done. Next part says, what percentage of the boys who took the exam got grade 1 to 3? So remember now, grade 1 to 3 is 162. We worked out already. See it? 1 to 3 is 162. They didn't show, so we have to work it out. And it's out of 200 persons. We want a fraction of 162 out of 200 persons. So it's 162 over 200, which becomes 81 out of 100. So it becomes 81%, right? Good. So this becomes 162 boys out of the 200 boys. To get to that percentage, multiply that by 100. It works out nicely to 81%. I don't need no calculator for that. Let's divide by the 2. Good? 81%. It says, considering the standard deviations in the table, compare the performance of the boys and the girls. All right, let's look at the standard deviation now. So these are the standard deviations. All right. So what happened is that the standard deviation of the boys is higher than the standard deviation of the girls. What does that mean in simple terms? Now, firstly, standard deviation is a measure of spread in relation to the mean grade. So the standard deviation of 8.2 is almost like saying the grades of the boys go 8.2 less than the mean up to 8.2 more than the mean grades. Right? So it's spread from 8.2 below the mean grade of the boys to 8.2 above the mean grade of the boys. In simple terms, that's what happened. In terms of the girls, the spread is less because the girls' grades spread to 6.3 below the mean grade up to about 6.3 above the mean grade. So it means that the boys' grades are spreading more widely from their mean grade as compared to the grades of the girls. But understand that? So like the girls' grades are closer to one another. The boys' grades spread out a little bit more than the girls. Get me? You cannot explain or compare standard deviation and don't mention that it is in reference to the mean grade, because standard deviation is taken using or calculated using the mean grade. It's a kind of measuring how the values or how the grades deviate from the mean grade. So looking at these figures, because the boys' grades higher, you can in simple terms say that the grades of the boys are more widely spread, more widely spread from their mean grade as compared to those of the girls. If you're referencing the girls for your explanation, you can say the grades of the girls are more closely spread from their mean grade in comparison to the grades of the boys. You understand that? Let's write it. So you're writing it either in reference from the girls or in reference from the boys. If you say it's the girls one you're talking about, you're going to say the girls one more closely spread. If it's the boys one you're using as a reference talking about the boys, you're going to say the boys' grades are more widely spread. I can say less closely spread, but just say more widely spread. Let's write something. There's only 1 mark for it, you know, so you don't expect no epistle. But you want a 1 mark, right? Make sure you say from the mean grade. All right, let's write something. Let's write something. That will suffice. In fact, I might write 2 things. I write 1 just for the purpose of the class, referencing the boys, and the other one I write it referencing the girls. And you write either one, you get the marks, right? Let's reference the boys first. The boys more widely spread, right? Because they go from 8.2 less than the mean to 8.2 more than the mean. So the more widely spread. Let's write it this way. So we can say something like the grades of the boys are more widely spread from their mean grade as compared to the girls. Right? That and then give you your marks. Or we can write it another way, referencing the girls. The girls' grades are more closely spread compared to the boy. But you have to say this. This is the key thing that you have to say. From their mean grade. Mean. You have to mention from the mean grade. Deviation, standard deviation, is measuring spread from the mean grade. You have to say that. All right? So let's write it the other way. We can say the grades of the girls. The grades of the girls are more closely spread, closer together, are more closely spread because they have a lower standard deviation. More closely spread. Spread is the word that they use for deviation in statistics, right? are more closely spread from their mean grade. It should be as compared to the boys. So when you compare the grades of the boys and the grades of the girls, that the girls' grades more close to one another. The boys' grades more wide. So like you have some boy get some low grade, you have some boy get some high grade. The girls' grade them kind of closer to one another. The girls them perform more similar to one another. While in the case of the boys grades vary wide from each other. Some boys getting low and some boys getting high, but the girls now kind of balance. Something like that. So again, you have to state this. You have to state this in your explanation. That is from the mean grade. You better go to that. One of those are right, you're good to go. All right, let's continue. 9 more marks. Let's go. Next question. All right, this one now. That's a measurement question now. Ready? It says the diagram below, not drawn to scale, shows a open cylinder. Okay, so open, guys. You can pour stuff in there. Open cylinder as a container. Mr. Down as a close. So you can pour stuff in it, right? And the top is open, nothing up on the top. All right. An open cylindrical container made from metal with a circular base and uniform thickness throughout. So the thickness of material here, so are the same thickness under the bottom down so throughout. Uniform thickness throughout. And so then put that in bold letters so you can't miss it. It says the length of the container from the top to the bottom is 120. See here from top to bottom is 120. And the inner and outer radii are 14 and 15 centimeters respectively. So what they're basically saying is that from here to the center out here is 15 centimeters, but from here to the inner one is only 14 centimeters. So it means that the thickness is 1 centimeter. But you can say that the thickness is 1 centimeter. So we can write that. So let's put that on there. 1 centimeters thick. See there? This is 1 centimeters thick. That's the thickness of the material that makes this cup. And they said throat, same thickness throat, is 1 centimeters thick. All right, so if you look at the bottom then, these have the same thickness. So it means that right here so is also 1 centimeter thick. 1 centimeter thick right there, don't it? So if the overall height is 120, and this is 1 centimeter thick, it means that the inner length inside here, so from top to bottom, internally, down here, so internally, is 119 centimeter. But can I say that? Internally, it is 119 centimeters. Because 120 includes the thickness down here, which is 1 centimeter. The question said it had the same thickness throughout, the uniform thickness throughout. So internally, it is 119 centimeters tall, like space inside here. All right, and the inner radius is 14 centimeters. But can I say that? The inner radius is 14 centimeters. All right, let's what them say now. Them say draw the cross-section view of the container showing the measurements of the inner and outer radii. So basically, you need to draw one circle, 2 circles, one are 14 and one are 15. And they have the same center. Get me? So you're drawing something like this. And they say, because them say draw, you really want to measure and draw it, right? So when I say sketch, you sketch. Because them say draw, you can use a compass and actually draw it, right? 14 centimeters, 15 centimeters, and draw them. All right? Let me draw it. Let me use the thing there and do it. Everything important. Let's use this and do it over here. And then I sketch it back on this. I'm going to clear this. Clear this. I don't know if it's so long 14 centimeters. This right now I can hold on this. 14. It won't be able to, I can't hold it on this, right? because 14 centimeter too wide on this. I don't know, maybe too wide on the paper. But just draw 2 circles. I don't like the fact that it says draw. So usually when I say draw, you have to go accurate. Right? So I don't know, but 14 centimeters. But anyway, you're gonna end up with something looking like this. So you're gonna have an outer circle and an inner circle. Right? And you're gonna label it up from here to here is 14 centimeters, and from here to here is 15 centimeters, and then the thickness is 1 centimeter. That's a cross section. But as I'm not, and like this is a material around here, so it's a material. That's like the rim of the thing. It's a different color. Let's just purple. That's it. So you draw 2 circles, make them 1 centimeter apart. You can measure at 14 centimeter and draw it and you can fit on the paper in the space that they give you. You'll find. Otherwise, just draw 2 circles. Try and make them 1 centimeter apart and give them that. All right? Because they said draw. Them say sketch, then thing. But anyway, that's it. It says show that the capacity of a container is this. Now, the capacity is the inner volume. Capacity is the inner volume, the inside space, like a cup where you can put stuff in it, right? So we're talking about the volume of the space inside here. This volume of the space inside here. Volume is cross-sectional area times length, right? Because the object uniform cross-section, that's what we learned. So the inner volume. Let's call that inner volume. The capacity is the inner volume. Inner volume becomes the capacity. That is VI. Let's call it VI inner volume. Is the cross-sectional area of the inner space times the length of the inner space. Remember, volume is cross-sectional area times length, right? That internal area is pi r squared, where the inner radius is 14. Let's write it pi r squared, and the length was 190. Note it. Right? Let's call it pi r squared h. And let's put all of this as the inner. Talking about the inner space. Inner dimensions, right? And then I must use pi as 22/7. You can glimpse it there. See it there? 22/7 for pi. Let's put in the values. So the pi is 22/7. The inner radius is 14. It's 14 squared. And the height is 119. The inner height is 119, as I showed you. 119 is the inner height. See there? Because the thickness is 1 centimeters. So the bottom also has a thickness of 1 centimeter. Because when the top alone open, right? It's a container. It's a container, the bottom must close, right? Good. So it's 119. So let's do this calculation now and see what we get. We're supposed to get this figure. We'll do this calculation. Let's see. Equals pi r squared h. All right, let's see. Let's see what we get. So it's a fraction, no, 22/7 times, that's a pi, 14 squared, pi r squared, and then times 119. Voila! 73,304 centimeters cubed. Shown. Or better yet. We're not shown. Better yet. Quite easily brushed aside. Soft. With a capital T. Yeah. Let's go. Next part. Says, determine the volume of material used to make the container. All right. So the volume of material used to make the container, you're going to calculate the volume of everything, including the space inside. So that is the total outer volume minus the volume of the space inside. That gives you the volume of material used to make. Let's set up like this. the volume of material equals volume outer minus volume inner. Just say it like that. Volume outer, meaning the outer volume, minus the inner volume. The outer volume is still pi r squared, but that's the radius different. So let's set up like this. It becomes pi, let's use big R for the R, the outer radius. Pi r squared, I use big H for the overall height. Pi r squared H minus the inner volume we just worked out just a while ago. Is 73304. Let's put in these values now. The pi is 22/7. The outer radius is 15, so we're going to put 15 squared. And the overall height was 120. And you're subtracting this 73304. That's what we're calculating. All right, let's work it out now. So it's pi 22/7 times 15 squared times the overall height of everything is 120. And they're subtracting 73304. And I'm getting 11553. That's going to write that to the nearest whole number. 11553 centimeters cubed. Want to get that? That's what I got in the test? Wanna bright. Very good. All right. That's a, Got it right. Good. All right, so that's the volume of the material, right? The material itself, the metal material, that's the volume of it. All right, next part now says, given that the density of the material, the density, those who do the physics or chemistry know that density is mass over volume. So they're helping you. They put it here on the formula paper. But they didn't have to give you this. Because they said the density is 22 grams per cm cube. You see this? In simple terms, it means 1 cm cube corresponds to 2.2 grams. That's what it means, you know, like a ratio just the same, you know. Every cm cube of that metal is 2.2 grams if you weight. That's all it means in simple terms. So they did not have to give you this formula. They're helping you, so they give you that, but they didn't have to give you. Right? Density is mass over volume. Huh?
Your mic was off. Your mic was off a while ago.
Oh, for very long?
For like a good minute.
You serious? Well, I hope it's being recorded, and I hope you can watch about the recording. I don't know what happened. I didn't mute the mic. I didn't touch this thing at all. I don't know, Rasta, I don't know. Because I'm still connected. I'm still seeing myself. Let me check this thing. Hold on. I didn't touch this. Still open. See it there? All right. I hope it was being recorded. I don't know. I don't want to go back. I don't know how far back I need to go. It's for a good minute. But the calculation is there. I can see it. So, all right. Let's just continue with this part. So I'm saying they did not have to give us this, right? But they gave it to us so we can use it. He said determine the mass in kilograms though, in kilograms of the empty container. Remember, we just worked out that the volume of the material is 11553 cm cube. You want to know what mass that is. So if density is mass over volume and the density is 2.2, you can set up, you know. And say based on this, if you transpose the volume over here, you can basically say that based on this formula that they gave us, the mass is going to be equal to the density times the volume. That's right, D for density times volume. That's what the mass is going to be, you know. The mass is going to be the density, which is the 2.2 times the volume, which is this. So the mass is going to be 2.2, but that is grams, times the volume of 11553. Where you get this? You get it in grams, because this is 2.2 grams per cm cube. So you work this out to get it in grams, and to get kilograms, you have to divide by 1,000, right? 1,000 kilograms, 1,000 grams make a kilogram. So this is 2.2 times 11553. You're getting 25,414.6 grams. 1 kilograms, I have to divide by 1,000. So the decimal point is coming here to get kilograms. So I would just give them 25.4 kilograms to 3 significant figures. That would be the mass. But understand that? That would be the answer. Very good? All right. And as I said, we could have just used this information if they did not give us that formula. That's what this means. It means that 1 cm cube is 2.2 grams. And if you want to know this amount of cm cube, you just basically multiply this ratio by it, by that value. And you're going to get the same answer. All right. Let's not digress. Let's continue. That finishes another 9 marks. Let's continue again. Next part is number 7. Wow. Number 7 is our pattern question. This is a make-up time question. So if you're lagging behind, this you can make up some time. Because we allocate 15 minutes for it. We can literally finish it in 5 minutes. This question, all right? Let's go. It says a sequence of figures is made from joining polygons of size 1 unit in length. The first 3 figures in the sequence are shown. So these broken lines are not actual lines. You can see that, right? So when you draw your fourth diagram, you have to draw it broken as well. So draw the fourth figure in the sequence. So basically, like you're adding on back one of these little hot-looking things onto the third figure. So like I would add on another one here, something like this. Let me see if I can draw it. Like I'm adding on another one of this here. Right? And then I will put everything together. So I'm going to draw it off this. I've used the technology that I have available to me. I'm tracing it over this and then move it out as my fourth diagram. Don't get jealous as I can do this. All right. Don't get jealous. Figure number 4 right there. How that look? Quick and fast. Don't get jealous. Yeah. Better go to that. Figure 4. Figure 4. All right. Beautiful. Next one. This one now gives us this pattern. So study the pattern of numbers in each row. Each row relates to one of the figures in the sequence on page 23. Some rows have not been included in the table. Complete the rows numbered 1, 2, and 3. That's this row, and that row. So I always like to fill out my formula row first because it helps me with these sometimes. All right, it helps us sometimes. So I'm going to fill out this one first. Stop singing. So looking at the pattern. I know so the mathematics nice, you know, if like you want to sing, that is fine, but we're disturbing. All right. So you look and see that this figure matches the figure number in the formula, don't it? So that is the n. So I put that as of n in my formula right here to start with the n. And then if I look at the pattern, it's always a +2. So I'm going to put my +2. And then when I come up here, this is always 2 times this figure number. You see that? Clearly, 2 times, don't it? 2 times the figure number. So I'm going to add +2n. That's the formula in there. And then over here now really is the result. But you can also look at it and realize that it's going up by 3, don't it? So I know so 3n starts the formula. That's all? So 3n starts the formula down here. And because the first figure actually has 5, 3 times 1 is 3. I need to add a 2 to make it 5. So it becomes 3n plus 2. But if you look here and here, see that it actually works out to the same thing. Because this n and this 2n is 3n, and they have the +2 right here. This is what we have. All right, so this is like just a formula to work it out, the final thing. But that is it. So once I have this now, I can fill this out, right? So here the 6 is the n and 2n. So here becomes 6 plus 2, then 2 times 6 is 12. What I got at that? Okay? And then here I'm dropping the 6 on the formula for this line. 3, 6 are 18, 18 plus 2 are 20. So this figure right here is 20. What I got at that? Then for this row, this formula now equals 65. The formula is 65. So it means that inside here, the 3n plus 2 is equal to 65. Subtract the 2 first, I'm going to get 3n equals 63. Divide by the 3, I'm going to get n equals 21. So I'm putting 21 here for my n. Now that I know that my n is 21, I drop it here and I get 21 plus the 2 plus, and then 21, 2 times 21 is 42. So it's plus 42. And your table done. Quick and fast. Next one. Show that no figure has 100 units per meter. Remember the per meter is in this line, right? Per meter. So basically you're saying that this formula can't equal 1,000 for a natural number n. A natural number is a counting number. That's what you need to show. All right. So we're gonna put that equals n and show that there's put the 3n plus 2 equal 100 as if we're trying to find the value of n. And if the value of n is not a whole number, a natural number, it means that there's no figure with 100 lines. So we're gonna test, like we're doing a test of 3n plus 2 equals 100. Subtract the 2 first, you will get 3n equals 98. 98, n will be equal to 98 divided by 3, which is what? Work it out for me quick, the calculator. 98 divided by 3 is what? How much can you get? Yeah. How much? 32.7, which cannot be a natural number. So we can say not a natural number. 37.2 is not a natural number. 32.7, sorry, is not a counting number. We can say natural number. Let's use the right term. Therefore, show that. Therefore, shown. So here we basically have to tell them, you know, n has to be a natural number. So here we can maybe state it. N has to be a natural. And a natural number is also called a counting number. For this proof, and we show that for 100, it's coming out to a value that is not natural. So that is it. We can use, maybe do it. We can do it this way. Change that style to red. All right. N has to be a counting number. Okay, you're counting the number of patterns. You cannot have 32.7 patterns. All right. Cannot have that. So that's what you'd have to have for the total to be 100. And so that is it. All right. Next question is number 8. We're going into section 2 now. All right. This question says, compute the table for this function, a quadratic function. Remember, quadratic function is symmetrical. This one, the square term is negative, so we know it's going to have a frown shape. Right? And we can actually look at the values and know. So look here now. These x values going up by the same interval of 1. So the y values have to be symmetrical. So because I have this 0 here and this 0 here, a value outside of this 0 is 5, so a value outside of this 0 must also be 5. A value inward of this 0 is 3, so a value inward of this 0 must also be 3. So there it is, my table done. quick and fast, nice and easy. 1 mark for that. You cannot penalize you for having knowledge of the symmetry of the values. The values have to be symmetrical. The values change the same way outwards from the axis of symmetry. Right? The y values, they change the same way outwards from the axis of symmetry. Remember the graph shape like this, the maximum from that axis of symmetry, the distance from the axis of symmetry is the same outwards to your y values. That's how it is. But if you want, you can calculate them. Huh? Where? Yeah, -5. Yeah, not 5, -5. Just like this. Thanks. All right? But that's how you can just look at it and put them in. But if you're calculating, you'd have to plug the -2 in there. You have to plug the -2 there and there. All right? And you'd have to plug the 3 inside here and here. So if you want to show the work, it's only 1 mark for it, you know. Look, it's only 1 mark for it, you know. So I think they wanted to use the symmetry of the values to get this one. That's only 1 mark for it. 1 mark. I don't know why I do so much calculation for 1 mark. Because to get this one by calculation, you have to put the -2 in this. And you will calculate f of -2. And it will be 3 plus 2 times -2 minus -2 squared. It will work out to be -5 just the same. And for this one, you have to put 2 in there. So it will be f of 2, which will be 3 plus 2 times 2 minus 2 squared. And that will work out to be 3 just the same. But you can look at the symmetry of the values and get it. All right, look at the symmetry of the values and get it. Let me change. Maybe it's a kind of color code one to do it. So I'm saying this outwards from here, the same as this outwards from here. And then use the red for the other side. This one inwards from the 0 must come this way also from the 0. The values are symmetrical about the axis of symmetry. And I know that this is the axis of symmetry. Oh, I know. Let me tell you, I know that this is the axis of symmetry. For sure. Because where the y values equal 0, these are my 2 roots. These are the points where I cut the x-axis. So this is a root. And this is also a root. The average of your root values is always equal to the axis of symmetry. And I average this and this, I'm getting 1. Right? So see there, the roots. The roots are the points of the graph would intersect the x-axis or no. So see there, the roots on this function are x equal -1 and x equals 3, because it corresponds to where the y value equals 0. On the x-axis, y value equals 0. So the axis of symmetry equals the average of the roots. The more things you know, the better. All right? And the average of these 2 roots will be -1 plus 3 over 2. That equals 1. Axis of symmetry will become x equals 1. So see here, it's where x equals 1 right here. So it means that right here is my axis on the function. So this is my maximum point. So that becomes my maximum point. Corresponds to my maximum point. Is a point 1,4. Maximum point is that point. Sometimes they will give you a graph and don't show the maximum point. You have to calculate it, but this table shows the maximum point. You get me? So one of the points presented here is the maximum point because it corresponds to the axis of symmetry, which is the average of your roots values. Remember, the roots values are the x values where the y values equal 0. So these 2 are my roots values. These 2 values, this and this, are my 2 roots values. The 2 x values where the graph intersect x-axis. On x-axis, the y value is 0. The average of the roots is the axis of symmetry. So the axis of symmetry value is x equals 1, which is right here. The y value corresponding to that value is my maximum value on the function. So the maximum point is 1, 4. All right, let's go. Next thing I want us to do now is basically complete the graph. All right, so the 2 points I didn't put in for us, I put in all these points for us. And what points I didn't put in for us? I didn't put in for us this one, which is -2, 5. Let's put it in. No, -2, -5. -2, -5. Right down here. -2, -5. This point down here. All right, and also didn't put in this point for us, which is 2, 3. 2, 3. So 2, 3 right here. Right here. And this is a maximum point. So basically just drawing a smooth curve through those points now. Right? Let me mark them for you. All these points. You're drawing a smooth curve through them. All right, and let's draw it in blue. So I'm just gonna go like that. And I'm gonna just go like that. That's my sketch. Simple as that. Good? It's a curve, a quadratic curve. Remember, it's a quadratic curve. All right, so the question is must put in the points and draw the function. That's it. What else I want us to do now? I want us to use the graphs. I have to show lines on the graph to get the coordinates of the maximum point. Maximum point just said was 1, 4. Right up here. Let's put it up there. Maximum point is 1, 4 right here. This point is the maximum point. 1, 4. What else I want? I want the range of values where f of x is greater than 0. This means where your y values are greater than 0. That's what that means. It means where the y values are greater than 0. And greater than 0 means above the x-axis. So what is the range of x values? Or is the graph is above the x-axis? That's what that means. So if you come up here, look at it. The graph goes above the x-axis after it passes that point. Remember, think of the graph as if it's going from left to right. So like you're going along the graph from left to right, this way, up that way, and then coming back down this way. Think of it that way. So it goes above the x-axis. It goes above the x-axis here, and then comes back on the x-axis here. So it's above the x-axis everywhere in this section is above the x-axis, which is between these two x values. So when the x value is less than this one, less than 3, or greater than this value, greater than -1. That's when the graph is above the x-axis. Less than 3, greater than -1. Between -1 and 3. Let me just copy this down. That's when it's above the x-axis. Paste that as my answer down here. All right, so this is it. Right here, that's my answer. That's my answer right there. And the question next says, what is the gradient? What is the gradient of the function at x equals 1? X equals 1 is that same maximum point, you know. X equals 1 on the graph is the maximum point. 1, 4. What's the gradient at that point? So the gradient of the graph, take this off. This is something that we're going to do. Will be the gradient of a tangent to the graph. At this maximum turning point, the tangent would be this horizontal line. That would be the tangent at x equals 1. Let me write it out. Tangent at x equals 1. It's horizontal. Horizontal line has 0 gradient. Gradient equals 0. The gradient of a curve and the gradient of a tangent is the same. Right? So if I want to find the gradient of a curve, suppose I wanted the gradient of a curve at this point. I would have to draw a tangent at that point, like so. Right here. I would have to draw a tangent passing through this one point and find the gradient of that tangent. That would be the gradient of a curve at this point if I wanted it there. And after I draw the tangent, I would have to look and find another point, like maybe right here, and use these 2 points to calculate the gradient of that tangent, and then that will be the gradient of a curve at that point. I know I haven't done this in class as yet. We're going to be doing it sometime soon when we do the topic of rates of change, gradient of curves. Right? So if you're not understanding this, don't worry yourself. We're going to cover this one of these days before exam in the last 8 weeks. Easy stuff. All right. That's why I tell everybody, get your rulers, get the geometry sets, and so on, because we have these things left to do. That's some one-day topics that we have left. We're going to have the curve at this point. Is going to have this tangent. The tangent is horizontal at that point. The gradient is 0. So the answer for this one is just 0. 0. Gradient equals 0. The gradient at that maximum point or at a minimum point is always 0. That's something else that you good to know. The gradient at a maximum point or at a minimum point and the quadratic function is always 0. At a maximum point or at a minimum point where the graph turns at a turning point, the gradient is always 0. Gradient is 0. 1 mark for that. So if you didn't know this one, no problem. No problem. All right? That's why we have to do the paper sometime. Our next part says, Mr. Thomas makes X bottles of juice and Y cakes each day. X bottles of juice and Y cakes each day. To supply his customers, he makes at least 20 bottles. At least 20 bottles means 20 bottles or more. Remember, X is the number of bottles. He makes at least 20. So right away, you say X have to be greater than or equal to 20 based on that statement. At least 20 bottles means 20 bottles or more. And he makes no more than 15. 15 is the maximum number of cakes he makes. 15 is the maximum. No more than 15. So he makes 15 or less. So the number of cakes, which is Y, has to be less than or equal to 15. Those are the two inequalities that are asking us for there. Easy as that. The number of bottles, X, must be at least 20, meaning 20 or more. The number of cakes, the maximum is 15. He makes no more than 15. 15 is the most he makes. So make 15 or less cakes. So these are the two inequalities for this part. It says each day Mr. Thomas uses $163 to make his bottles of juice and cakes. So he can't spend more than $163. So it's either I'm spending $163 full or he spends less. All right? He said the cost to make a bottle of juice is $3.50. So for the juice, he's spending $3.50 times X. And he's spending $5.25 for each cake. So the money he's spending on cake is $5.25 times Y. That's the total money he's spending. Remember, he has X juices, X bottles, and he's spending $3.50 each. So this is the total money he's spending on the bottles of juice. And he makes Y cakes and spend this amount for each of them. So the money that he's spending on the cake is $5.25 times Y. And all of this money can't pass 163. So it has to be either I'm spending less than the 163 or the whole 163. So that is it. That's the inequality. But I go to that. That's the inequality for that one. This is the total amount that he spends. Either spends all of it or less than it. And this represents the total amount. And we know says this amount. That's the inequality. Next part says, show that on any day it is not possible for him to make 50 bottles of juice, that is X equals 50, and 12 cakes, that is Y equals 12. In other words, what they're saying, you can't have these two numbers on the function. So what we're gonna do is look how much money needed to do this. And if it go over the 163, you know, say in can't work. You understand? What I say that? Good. So the amount of money needed. Let's do it this way. Amount needed. Amount needed to spend. Money needed. That's right, word of money. Money needed. It's showing you $50 in spend per each bottle. So you would need $250 times 50 bottles. Plus, you spend $5.25 on a cake. Now, what did you say? $5.25. Yes, $5.25 on each cake. Plus, you would need $5.25 for each of the 12 cakes. Let's see what this works out to. If you come to more than $163, you can't do this. Because you can only spend $163. That's what it works out. How much? $175? Wow. This is equal to $175. Mr. Powell said. Who said it? Mr. Powell? Yeah, Mr. Powell said that. Now load you up. $175. This is greater than $163, don't it? 175 is actually greater than 163. And you can't spend more than 163. See that? Therefore, cannot. Therefore, not possible. Therefore, not possible. Do that and CSEC give you your marks. So you have to reference the $175 against the limit of 63. Because 175 is more than 163. You can only spend 163 or less. Understand? So once the amount required to spend is more than 163, can't work. Better go to that. Online, better go to that. Are you still there?
Yes, sir.
Yes, beautiful, yes, beautiful. What class full as 25 people online, well, including two of me. That's about 22 persons. Yes? Huh? Huh? Can I hear nothing? Yes, can I hear him? Huh? And 165 this? I'm more than 165 work out too? I'm working out myself because you don't yourself. I know. Let's 167? Let me work it out myself. I want to work it out this. I'm questioning that figure. Let's see. So it's 3.5 times 50 plus 5.25 times 12. 238. I want to get 175 from. Lord of Mr. Paul. 238. This is $238. It's still more than it is, right? You get the picture. That's the concept anyway. So you had the wrong value, but that is the concept. So it's actually $238 that work out. It's too much money in need. You don't have so much, so you can't make so much, right? Yeah, bro. Let's go. Next question. Next question is number 9. Beautiful. So it starts out with our typical circle theory question. All right. It said the diagram below not drawn to scale shows a circle. It says points P, Q, R, T, and V are on the circumference. QRS is a straight line, so that's a secant line. And it's not a tangent line, guys. It's not a tangent. So don't go treating this like a tangent, this one. A lot of people made that mistake. Treat this like a tangent. A tangent only touches at a single point only. All right? It's a straight line. It says PVR is 75 degrees right here. And TRS is 60 degrees right in here. That's the angle right here. 60 degrees. So they tell us the information is shown on the diagram. All right? It says determine the value of each of the following angles. Show detailed working where necessary and give a reason to support your answer. First angle I want is angle PTR. PTR. They want this angle. I will find that angle. Find the arc or the chord that is subtending the angle. Look what else the arc or the chord is doing. So to find that arc, you come back along the angle lines until you reach the circle, circumference. That's here to here. I don't see a chord across there. They didn't show me a chord, but I can see the chord, the arc, sorry, that is subtending that angle. This arc is subtending that angle. You can imagine a chord inside here just the same if you want. What else is that arc doing? It is subtending this angle over here, so try it in a different color for you. The same arc or the chord is subtending this angle over here. So these two angles are in the same segment subtended by the same chord or arc. And so they are equal, same segment rule. They are equal. So that angle that I want is 75 degrees. Angle in the same segment subtended by the same chord or by the same arc are equal. So I'm going to write this equals 75 degrees. That's this angle up here. Let's put on the diagram as I work it out. So this angle up here is 75 degrees. Equal to the one there. Same segment rule. So the angle is 75 degrees. So give a reason. Angles in the same segment are equal. If you want to spell out everything, angles in the same segment subtended by the same chord or arc are equal. See here? Angles in the same segment subtended by the same arc or chord, same arc or chord, those angles are equal. But I feel if you wrote just this in the exam, they give it the marks. This angles in the same segment are equal. If you just wrote that alone, they give it a marks. Angles in the same segment are equal. So anybody wrote just that, can take the marks. Angles in the same segment are equal. All right. Next question is for us to find angle TPQ. Let's see where that is. Angle TPQ. Angle TPQ. TPQ. That's this angle right here. As I say, that is one of the angles in the cyclic quadrilateral. So it means that these two angles across from each other, they are supplementary. They add up to 180 degrees. But then this angle inside here completes the angle on the straight line with this one. So it means that that is 120 degrees, because total angle on a straight line is 120. And if these two across here must be 180, then this over here also must be 60. But there's another rule, you know, that says the external angle of a cyclic quadrilateral equals the opposite interior angle, you know. There's a rule over like that too. But we're not bother giving you that one, because it can be figured out. See it here? Look. So you have this cyclic quadrilateral. Let me show you. More maths equals better maths. We have this cyclic quadrilateral here, right? So you see this angle right here? That's an external angle of the cyclic quadrilateral, because that's an extension. You see that angle, an external angle of the cyclic quadrilateral, it's equal to the opposite interior angle. So what is 60? They could say that as well. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So if you take the extension and a cyclic quadrilateral and get the exterior angle, that angle equals the opposite interior. And it makes sense because remember now that these two, let's look at it. If we call this angle here, so theta. 60 plus theta is 180 because total angle of straight line is 180. And then 60 plus theta over here, so equal 180 because opposite angles in a cycle quadrilateral also equal 180. So them two equal 180. And then them two here also equal 180. So them two equal 180 because of a straight line. And them two equal 180 because of the opposite angles in a cycle. So it works down that the exterior angle is equal to the opposite interior angle. We're going to do the mathematics the easy way and learn. So this angle equal that angle there, so, and vice versa. Get me? Let's do it that way. Exterior angle of a cycle quadrilateral equal the opposite interior angle. That's the reason. So let's write that. So this angle equals 60 degrees. Mathematics the easy way. So I want to say the exterior angle of a cyclic, so it's a new one, right? I didn't give it this one before. A cyclic quad equals the opposite interior angle. And that's why that one is 60 degrees. The opposite interior and the exterior equal. So I'll keep it that way. Keep it simple. Next one. They want us to find the obtuse angle POR, where O is the center of a circle. I know they did not show us O on the diagram. But I want us to find angle POR. Let's put it on and look at it. All right, let's take this off. So I want us now to find angle POR. I'm going to take out the 60 degree here. I cannot in the way. All right, let's draw this in blue. So I want to put in where O could possibly be, right? So O would be the intersection of diagonals here and here. All right. So O is possible right here. So O is possible right here, the center of the circle. And they're basically asking us, this is O. They're asking us for this angle. But that's an angle at the center. So we're going to use the center rule. And that angle at the center right now, is subtended by this arc. Or if you want, you can put in the chord subtending that angle at the center. That same chord and that same arc, they are subtending this angle up here, the circumference. 75. But the center rule says, angle at center is twice angle at circumference when they are subtended by the same arc or by the same chord. So it means that this angle inside here, so is 2 times 75, 150 degrees. So that angle at center is twice angle at circumference. It's the angle at center rule. You have to remember the rules. Center rule. Angle at center is twice angle at circumference. Go back and look over that topic. So simply 2 times 75 degrees. This angle that I want equals 2 times 75 degrees, which is equal to 150 degrees. Reason? Because it is the angle at the center that is subtended by a chord or by an arc, that is subtending 75 at the circumference. So let's write that. Angle at center is twice angle at circumference. That's it. You can continue and say when subtended by the same chord, this case is the arc, because they didn't show the chord, by the same arc or the same chord. Now, if you stop it right here, and I show that, they give it a marks. Angle at center is twice angle at circumference. If you stop it right there, they give it a marks. If you want to finish it, they can add on when subtended by the same chord or same arc. If you stop it where what I wrote in red, you get the marks just the same. That's the key thing about it. All right, next part. Or next question. All right, so this question was a mistake, and I corrected that on the paper that I gave you. So this is really S2, based on the reading of this question. This is really S2, and this is really S1. And so you have to be smart in the exam room sometimes and know when the paper actually has an error on it. Sometimes what they'll do, when they pick up the error, they'll put an amendment or call an addendum or something like that, and give it to you in the exam room. And I might give you a separate paper with this diagram on it, and so on. They do that sometimes, right? So I don't know if that was the case when I set this paper, but based on the wording, then this will be the S1 and this will be the S2. All right? You couldn't work the other way around. All right? So this question says, a person at the top of a lighthouse, TV, it's a lighthouse here, so let me just go back for the group. This is a lighthouse right here. He sees two ships, S1 and S2, S1 and S2, approaching the coast as illustrated in the diagram below. The angle of depression and the angle of depression are 12 and 20 respectively. So because I use the word respectively, we'll have to say the 12 has to do with the S1 and the 20 has to do with the S2. And that's why the thing must be wrong. Because the angle of depression is, remember, is measured from this horizontal line looking down. So the 12 degrees must be less than the 20 degrees, right? So this angle is 12 degrees looking down, right here. Let's use the radic. This is 12 degrees looking down. Right here is 12. And then this one is 20 degrees looking down. 20 degrees. So you say the 12 one must be to the S1 out here. That's why that has to be the S1. See that? And then the 20 degrees will be down here, must be the S2. And so they said respectively, and that's why they had the position of the S1 and the S2 can't be correct. I don't know what they'll do in a case like this if they don't give it the amendment and students get confused. I don't know. But if I'm in the exam and I realize that, may I change this right or so? Change them, because I know they make mistakes. They're not perfect. Hopefully they don't make any mistake, because they make mistakes on paper sometimes and throw students off, I tell you. You understand? I see questions where they give values that are so inconsistent. Students are there trying to waste time trying to figure out what to do because the value is just inconsistent. It makes no sense. They're just wrong. I don't know what they do in those situations, but it happens. All right. Anyway, it says the ships are 110 meters apart. So it means that right here is 110. So this is the only distance they give us. So we're gonna have to work in another triangle here. You can't work over this triangle, you don't have no distance over there. So you're gonna have to work in that triangle to begin with, this triangle. Because the only place you have any distance. You get me? All right. And it's section 2. So since it's section 2, you must expect to use sine rule and cosine rule. You must realize that section 1 is your Pythagoras' theorem question. We did that already for one question earlier. Pythagoras' theorem and so-called tower. Section 1. Once you're doing trigonometry, section 2, sine rule and cosine rule. You're more than likely have to use at some stage. All right? So that is it. So we have to realize, remember, that the angle of depression from the top equals the angle of elevation from the bottom. So I'm going to fill in right away, since this angle up here is 12, the angle of elevation looking up here is also 12. Because see the Z there? So the inner side 12. Similarly, angle of depression down here is 20. So the angle of elevation up here is also 20. Angle of depression from the top equals angle of elevation from the bottom, looking the other way. I'm filling in those information right away. So this angle down here so is 12 degrees. Put it on a diagram. And this angle inside here so is 20 degrees. Put it on the diagram. And then now, because I have to work in this triangle, I want an angle in there. This is 20 and this is 12. The difference is 8. So right inside here so it's 8 degrees. I put on a different color for you. The angle in this triangle inside here is 8 degrees. Right inside here so is 8 degrees. So now I can use sine rule, because I can use this pair, angle and side opposite each other. See that? With this pair, angle and side opposite each other. See that? So basically that is what we're going to do. Because the question then, after it asks us, it says complete the diagram by inserting angle of depression and the distance between the two shapes. That is it. Put in everything. Next part now says calculate the distance TS. Distance TS is this length. Let's just call it X for reference. All right? Let's just say that is equal to X and post put it X. So I'm going to have to work with not TS. Let's call this distance X. Talking about this line, X. Let's call it X right here. So I can work in this triangle now and use sine rule. This angle and this side opposite each other. This angle and this side opposite each other. So sine rule will give me the X. Angle and side opposite each other. Sine rule. Remember, once you have that, sine rule. Once you have an angle and a side opposite each other, where you know both of them, you can use the sine rule in a triangle that is not a right angle triangle. You can't use so-called tower in that triangle. You cannot use Pythagoras theorem in that triangle. It is not a right angle triangle. So this is one is set up for sine rule. So I'm going to say sine rule. Tell the examiner what I'm doing. Sine rule for X. I'm calling it X. I place it here as X. Start with what you want. X over sine of the angle opposite the X is 12 degrees. See? The angle opposite the X is 12 degrees. Equals the distance that we know is 110 over sine of the angle opposite 110 is the sine of 8 degrees. You take this sine of 12 and multiply it and make sure you put it behind the number. You always put the trig function behind the number. Don't put it in front. So the X becomes 110 sine of 12 degrees divided by the sine of 8 degrees. I'm going to work it out with the calculator now. I would like to know if anybody got this one. Nobody here got this one? So it's 110. Make sure the characters in degrees. Yes, it is. I can see the DEG at the top there. Sine of 12 degrees over the sine of 8 degrees. I'm getting 164. All right. They didn't tell you, say, all right. See, they said the nearest meter. So it's 164 meters. 164 meters. When they say the nearest meter, I mean that they don't put a decimal. Give it the nearest whole number. 164. Put it on the diagram. So I now know that the X is 164. Let me write it like this. This X is 164. Meters. Know that I have this, that's a right angle triangle. That's my hypotenuse. I can work in this triangle now using so-called tower. Because I know I have an angle in there and I have that hypotenuse. So I can work in there now, right? Good to go now. What's the next question? They must ask for the height. They must ask for that height. That's also what these questions are. See there, the height of the lighthouse, TB. So working in this triangle now, to this angle, TB is the opposite, and this here is the hypotenuse. Opposite and hypotenuse, we're going to use tan. We're going to use sine, sorry, sine. So-called tower, sine, opposite and hypotenuse. So sine of the 20 equals the TB that we want over the hypotenuse. That's what we're going to use. All right, let me write it here since it's on the screen. I'm going to say sine of 20 degrees, write it here. Sine of 20 degrees equals the opposite side, which is TB, over the hypotenuse, which is 164. All right, let's start there. Let's move this down and work with that right here. And you want to find TB, you take the 164 and multiply it across here. So you're going to get the TB equals 164 sine of 20 degrees. All right. Therefore, TB, height of the pole, height of the tower, TB, is 164 sine of 20 degrees. 56 meters. That's it. 56 meters. Nice and easy. Time is it? 11:43. Finishing just now. Sorry, 1:43. 1:43. All right, finishing now. One more question. And we're done. One more question. One question left. Here, there, one question. Last one. All right, let's fly through this one now. Ready? This question gives us these matrices. Let me just write them out again, because what happens sometimes is that it's on the next page, you have to go, and I can't be coming back and forth. Let me just write them like this. So we can copy this down. All right, let's copy them from now. When I go on the next page, I'll just paste them on. All right, let's go. Question says, given these three matrices, using a calculator to support your answer, explain whether P is singular or not. Remember, it is singular. Singular means it has no inverse. If it is singular, has no inverse. Because the determinant is equal to 0. So the determinant is not equal to 0, it is not singular, and it has an inverse. So to determine if it is singular or not, we need to calculate the value of the determinant. You get me? So let's do that now. So the determinant of P, say the supplied by a calculation. You have to show the calculation. Calculation is to calculate the determinant of P. What's the determinant equal to? The first diagonal product here, the product of those two values, which is -1 times 5, minus the second diagonal product. Some teachers call it leading diagonal and trailing diagonal, leading diagonal, following diagonal, main diagonal, secondary diagonal, no matter. Anything we mean first, other one here. Anything we mean second, or this one. All right? So the second diagonal product is 2 times 0, which is 0. So this works out to be -5. -5, I'm going to state it now. It is not 0. And I would maybe leave this on my exam paper too, you know. That little thing that I put there. That is saying to the examiner, yeah, I know my stuff. The part of my solution. So because this is not 0, I'm going to say P is non-singular. I'm going to say, therefore, P is not, I can say non-singular. And it therefore has an inverse. You can calculate that inverse for it. All right, that's the answer right there. Next part, 2 marks for doing that. Next part says, calculate PQ equals R. Oh, given that PQ equals R, you must find the value of A and B. Let's paste the thing now that we have. See here, that's what we have. And what telling us is that the P times the Q is equal to the R. Let's set it up. It means that -1205 times the AB is equal to the 1115. That's your classic matrices equation where you want to find this matrix here. You multiply the inverse of this one in front there. Good? Transpose the inverse of this one in front there. It's like you multiply both sides by the inverse. We have to multiply it in front. But shortcut, to put the inverse of this in front here. It has to go in front. Since it's in front on that side, it has to inverse that goes in front on the other side. Put it that way. So the AB is going to be equal to the -1205 to the -1. Let's put the -1 in the red to make sure that I'm talking about the inverse of this matrix times the 1115. So I need to calculate the inverse of this matrix right here. Inverse is 1 over the determinant, which we know already is -5, so we have to work those again, times the adjoint. And see, I run out of space. Let's make this smaller. All right, let's make it smaller. So this becomes equal to 1 over the determinant, which is -5, times the adjoint of this matrix. Or you do the adjoint. Interchange these two values on the first diagonal. Interchange them. So the 5 goes here, -1 goes there. Leave these two on the second diagonal where they are. Change the sign. So this 2 becomes a -2. This 0 stays as 0 because 0 no carry a sign. And that's the inverse right there now. And you're multiplying it now by the 1115. And what you normally do is do this calculation first, leave the fraction for last. So I'm going to do this calculation now by multiplying the 2 rows of this matrix by the 1 column. Leave the fraction for last. So this is going to become, and this is AB still calculated, AB. All right, so AB then becomes 1 over -5 times a 2 by 2 matrix. That's what this is going to work out to. I'm doing this calculation first. Let's show the steps now. Getting a 2 by 2 matrix. All right. How you do it again? This first value that we want, it is in the first row and the 1 column. So to get it, you multiply this first row by this 1 column. Or multiply a matrix. Multiply the first element in the row by the first element in the column. Second element in the row by the second element in the column. First element times first element. Second element times second element. First element times first element. Second element times second element. Ready now? 5 times 11 minus 2 times 15. 5 times 11 is 55. Minus 2 times 15 is -30. That's what I like with these now. This works out to a perfect multiple of the -5. That's why it's always good to leave the fraction for last. This value down here now that we want, this one down here. It is in the second row and the 1 column. So to get it, we're going to multiply this second row with this 1 column. Same thing again. First element times first element. Second element times second element. First element times first element. Second element times second element. Ready now? 0 times 11 minus 1 times 15. 0 times 11 is 0. Minus 1 times 15 is -15. And then this simplifies into 1 over -5 times, this becomes 55 minus 30 is 25. 0 minus 15 is -15. Dividing each of these values now by this -5. 25 divided by -5 is -5. -15 divided by -5 is +3. What do you go do that? You can't leave that as your answer. Because the question asks us for the value of A and B. So you cannot leave the matrix. You have to explicitly state the value for A and the value for B. So you're going to say A equals the -5 here, and the B equals 3. B equals 3. That's it. Better go to that. Beautiful. 3 whole marks for that. Next one. State a reason why this product is not possible. This is now talking about conformable or not. Remember, for the matrix multiplication to be conformable, or for matrices multiplication to be conformable or to be possible, the number of columns in the first matrix must match the number of rows in the second matrix. If you multiply these two, the Q, remember, is a 2 by 1 matrix, but the P is a 2 by 2 matrix. So if we're doing this, we'll be doing this multiplication would be a 2 by 1 times a 2 by 2. I'm writing this out on my exam paper, you know. And I'm going to circle these and say something like, these are not equal, not equal. Once those two numbers not equal in terms of the order of the matrices, the multiplication is not possible. We say it is non-conformable. And they write the reason. Simple. The number of columns in Q is not equal to the number of rows in P. That's the reason. Let's write that. Number of columns, the reason is that the number of columns in Q is the first matrix, is not equal to the number of rows in the second matrix. But because we know it says P, we cannot just write P. We don't have to say second matrix. But go to that. Q is the first matrix, so we don't have to say first matrix. We cannot say Q. P is the second matrix, but we don't have to say second matrix. We just say P. But okay with that? Good? Beautiful. Next one. Then we come to this vectors question. Last question. Last question. Somebody calling me. Hello? You're still in the middle of class. Still in the middle. We're not finished yet. No. All right, so we'll finish. Finish that short, man. Finish that short. Okay. All right, guys. Sorry about that. Right. So this question is a simple, quick, and fast exam done, you know. 3 marks for this. All right, let's get this 3 marks. 3 marks. It says OABC is a parallelogram, a like parallelogram in vectors. Because automatically you know that the opposite sides are equal vectors. They start labeling it for you. You have to keep the orientation of the labeling. So because they say OABC and they put the A here. They put the A here. O to A. It means that the star go clockwise already with orientation, you know. You cannot put B down here, so, and C up here, so. Cannot. Because that will now break the orientation that they are presenting. You understand? So how they give the letter, you have to keep in one orientation. So once they put the O here and the A here, the B have to come here, so must come there, so. That's the first thing that is important. All right? So you can't just randomly put it where you like. You have to follow this orientation and they deliberately put the A here because they are testing if you know, so the B must come right there, so. And then the C go there, so. But I go to that, that's the first thing. All right. Now putting on the vectors that they give us now. They said, X is the midpoint of A, B up here. So I'm going to put on a point for X right inside here. The midpoint right there is X. And then Y is the midpoint of BC. This is BC now. Y is the midpoint. So here is the BC. And that point is Y. All right. Then they give us some vectors now. It says OA is a vector R. Let's put it on now. This vector up here so is R, all of it. So it means over here, so the whole of this is also R. But the Y divides it half and half. So this side is the vector R. All of this is R2, you know, but because this is the midpoint, we're going to break it up and say this is half R, and this is also half of R. What good at that? What okay with that so far? Then it says OC is S. That's this side, this vector across this side is S. So when you say the whole of this side is also S because it's a vector parallelogram. And so we're going to label this side as S. No, as S, yeah, vector S. But because this is the midpoint, we're going to divide this as half S from here to here. And then the other half is also half S from here to here. So basically label the vector now so we know our way around with the vector diagram. So ready now? Pay attention to the arrows now. It says, given that OX plus OY is equal to this, where K is a constant, using a vectors method, find the value of K. So now we're going to find the value of K by working out what OX plus OY is actually. Compare it with this, and then we can see what the K is. You get me? Let's work out the OX plus the OY, see what it really is, and then we'll see what the K value is. But go to that? All right, let's work it out. Let's work out the OX and the OY exactly. Find out exactly what they are. So the OX plus the OY, you can put it all in one. Let's do the OX first. What is the OX? Look at the diagram. How do we go from O to X? Simple. You go R and then half S, don't it? But I agree with that? But I agree with that? So to go from O to X, you simply come up here, so R, and then you go half S. Remember, it's how you go around the diagram, right? So it's R plus half of S. That's the OX right there now. And then we're adding OY. O to Y. Talk to me the OY now. To go from O to Y, simply, we go S across here, and then half R right there. So, but can you see that? S half R. Let's write it. So we're going to add a S plus half of R. And then we're going to consolidate the values as they have done there. So we consolidate the R values, that's a R and half R. That's 1.5 R, don't it? 1.5 R, don't it? 1.5 is 3 over 2. Can I write 3 over 2 instead of 1.5? Let's put 3 over 2. So it's 3 over 2 R. Let's do the S values now. That's a half S and a S, a whole S. That's 1.5 S as well. 1.5 S. 1.5 again is 3 over 2. That's 3 over 2 S. And all they have done in their form is to factorize the constant out of it, where we can see that the constant is 3 over 2. So factorize the 3 over 2, we see we have the R plus S in the bracket. So it means that this value is K. So what it means now? So that we have this constant the same, but where they have the K, we now have the 3 over 2. Simple. So we can say, therefore, their K is our 3 over 2, and that is the answer. And that is that. Huh? Where you join? Where you join online for the classroom? You're in here, look on the board and says, you want your phone for dead? You want your phone dead, man. Everybody good with that? Everybody good? All right, so remember now, guys, no joke. Online and here. Any question you didn't get right, you go and redo the questions. You don't know what is coming on your exam paper. Sometimes they set back the exact same question. Sometimes they set back questions that are very, very similar, because the value is different. Any question you're exposed to, make sure you understand it. So I'm going to send the video in the group. You're going to redo the questions, especially the ones that they get wrong. If you did not do the paper, you need to go and do it. Use the video to help you. It's serious time now. All right? So, you know in the classroom, you're joining online tomorrow for the other paper. People online now coming into the classroom tomorrow. I will do the next paper tomorrow. So let me hear some grades. Everybody get over 25? Who get less than 25? Everybody get less than 25. That is good. Everybody get less than 25, okay, now, because we just start. We expect it to improve over the time. I sent in the group for the progress we need to be making. So if you're already ahead of 45, ahead of 25, very good. If you are already ahead of 25, we're good to go. Just make sure we're doing the next mock exam on the 30th at a chance. You get 30% or more. Don't fall back. We're going progress. By the time we get to the exam, we're going to be looking at 95%. You get me? We're going to be looking at 95%. But you have to do the work. Listen now, you have to do the work in order to get there. And what the work is, learn from your mistakes, correct the errors, make sure you work the questions. You're going to get familiar with everything that we're doing. And I know we still have 1 or 2 topics to finish off. That's fine. We'll get them all done. All right, guys. So see you in the classroom here online tomorrow. Students online, see you in the classroom tomorrow. I'm going to give you some work to do over the week that we're at champs. But if you so now get to it, we're going to do some work to do during the week we're at champs. Right? And I expect to go through that work the Sunday and the Monday after boys and girls stuff. You know, because the champs are keep, we are waste time. Them are do what them are do, we have to do what we are do. Our business is to get A's in this exam coming up. All right, cool. Bye, everybody. Bye online. Bye online. All right. Bye bye. Kiss I win jump big. That's a lacrosse.